Let's ask this question again. We already said many times that the climate always changes, it has always changed, and even if we were not around, it would be changing anyways. So, what is it that we have to worry about to decide whether climate change is real? Should I really worry about the current climate change being real or not, or whether we are causing it or not, right? And again, we'll go back to the past climates. We already talked about it, but let's look at it in a slightly different way. The detective work done by our good biogeochemistry people can take us back with the estimates of the deviations of the past climate in some global mean sense from a baseline which can be the 20th century or so. So these are anomalies, and you can see the temperature changes with respect to this baseline, which, once you are subtracting from some baseline, that baseline becomes zero, and you only look at deviations, positive and negative. So we can go back to the Cambrian. Remember, we had the pre-Cambrian and the post-Cambrian with a species explosion at the Cambrian 542 million years ago, and that time it was really warm. It was almost 8 degrees warmer than present in terms of global climate, global mean temperature anomaly from the baseline. And we are now talking about warming since the industrial revolution of 1.3 degrees, and you may have heard that we want to stay below 1.5 degrees centigrade by 2100 or 2 degrees centigrade by 2100, otherwise many bad things will happen then immediately. The question is, if it was 8 degrees warmer than the baseline at in the past, why do we have to worry about this 1.5 or 2 degrees centigrade warming? As I said in the last podcast, the main thing is that we are only around for the last 10,000 years or so here in the Holocene that we'll come back to, and we were not around at this time. So we are not worried about what will happen to the planet, and obviously we are not worrying too much about other species either right now. Actually, we should be, and many people are worrying about other species, and many are saying we are causing a large extinction of the other species and so on. So nonetheless, you can see that if you keep going from 542 million years forward, the temperatures have swung back and forth, and you already know from your expertise from previous podcasts that when it is down and cold, there are glacial periods, some smaller, some larger, and you also know that Ordovician, Silurian, Devonian, Carboniferous and so on, where plants suddenly exploded onto the land and planet and started photosynthesizing and taking down CO2 and cooled the temperatures as you expect when CO2 is reduced in the atmosphere, because it is a greenhouse gas, right? If you reduce it, you will not trap the outgoing thermal energy, so you will get colder and colder, and then something happens and it goes back up, because obviously you have orbital changes and we have internal feedbacks, positive feedbacks and so on. Warms again, cools again, and so you have ups and downs. And let's come to the last few million years where our ancestors, chimpanzees and gorillas, began to walk on 2 legs instead of all 4s, and our ancestors, more closer ancestors, Homo neanderthal, Neanderthalensis, Neanderthals, and Erectus and Habilis and other Homo lineages evolved, and there were other related lineages before that. Some of you may know, but if you don't know, don't worry about it, and so on. Okay, so we have had ice ages and deglacial periods and so on, and the temperature range has been large in the past and has been smaller here. But most important thing is, look at this place here from 10,000 or 12,000 years ago, as we came out of the last ice age, which peaked 21,000 years ago. So if you have seen those ice age movies, you may remember some of this told in a story nice story with all these animations and so on. So you can see the temperature over this period has hardly been deviating much from the baseline, maybe half a degree this way and half a degree that way. But you look at where we are through the last 150 years or so. This is 10,000 years, 2,000 years ago, and 150 years ago, and you can see we are beginning to go up, still very small compared to here. So we are still talking about a warming of 1.3 degrees C from the Industrial Revolution, let's say somewhere here. So this is what we are talking about, right? We have evolved as modern human beings, as agriculturalists, and then as industrial revolution, science, technology people in a very stable climate during the Holocene. So this is what we are worried about. If we are only used to stable climates and we start warming the planet so much and continue to warm it by increasing greenhouse gases, where will we go? So we can zoom in and look at just the last 65 million years ago, just for fun, when the dinosaurs went extinct because of the crashing meteorite and then everything that followed. So you can see again temperatures were very warm. They were 12-15 degrees warmer than present. Arctic had no ice, Antarctica had no glaciers, Greenland had no glaciers. There were green forests in the Arctic Circle, and mammoths and dinosaurs were happily wandering around. Well, make sure mammoths were around at that time as well. And then the dinosaurs went extinct and the CO2 increased some more to 50 million years ago, and then the CO2 and the temperatures began to drop, because one of the reasons is argued to be that India crashed into Asia and created the Himalayan mountains and created the monsoon, and the Himalayan mountains started to get weathered. Remember, when weathering happens, rocks lose their CO2, and the CO2 goes into the ocean and you begin to take it out of the atmosphere. So some drop in the CO2 happened, cooling happened more recently, and then we started coming out of all that cooling. The last glacier ended around 21,000 years ago, and from there till 10,000 years ago it began to warm. You can see it cooled and cooled and cooled from 135,000 years ago to about 21,000 years ago, and all because of changes in the orbit. Remember the ellipticity, the obliquity, and the precession, which gives us changes in the energy or the energy distribution from the sun. And then the ice albedo kicks in. You are now an expert in ice albedo. So if you started to build a glacier 135,000 years ago, then it'll get colder and colder, because glacier grows, albedo increases, more energy is sent back to space, and then once the glacier begins to melt, albedo drops, more energy is kept in the system, warmer, glacier disappearing, and then it disappeared to the extent that now we have glaciers only in a few mountains on Greenland and Antarctica, right? So there is the Holocene again, that is fairly flat when we became so powerful and innovative and started digging everywhere and deforesting and doing agriculture, grew in population and produced all these machines and so on and so forth. And this is also showing where we are likely to go into the future, which I talked about before in the last podcast, and we'll talk again when we come back and talk in the last chapter about future climate. Well, that's more important for you because you are still very young. So this, we said before, that depends, the future projections, the models we used, we can give them how the future of CO2 looks like, how the renewable energy will increase, and how we may capture the carbon and put it away somewhere, and so on and so forth. If we don't do much, we may end up again warming back to 8 or 10 degrees, and we will be back here somewhere. But remember, we were not here, we are only been here. Or we can be smart and start reducing our emissions and do more of renewable energy and efficiencies, electric vehicles and so on, and keep the temperatures to a very safe 1.5 or 2 degrees centigrade by 2100 and into the future. So that's your future. You are the future is yours, and you have to worry. As I said, we are here talking about whether climate change is real, and we can look at this Holocene again a little bit more. Now we are coming back from about 20 or 18,000 years to the present, so we are going forward in time, but starting 20,000 years ago or so. And this is ice accumulation, but you can think of temperatures as well. We were very cold 20,000 years ago because we were in an ice age, and then we have been warming and warming, so we are here. And this shows very, very nice work by a very famous glaciologist named Richard Alley, who speaks with so much enthusiasm that you will jump out of your seat and be so eager to learn, right? So he showed that things can change very fast. So it can get cold very fast and warm very fast, which we talked about before with ice albedo feedbacks. There are many details, but if you don't understand, don't worry about it. But main point again for us is here. Last 10,000 years have been fairly constant in temperature, and that's when we became agriculturalists and started growing more and more crops and started cutting more and more forests, and in population grew, and there were small deviations from the baseline. Again, these are anomalies in some sense, and you had a little bit of cooling, half a degree cooling, half a degree warming. So when it was warming, the Greenland glacier was reduced, and the Vikings invaded Greenland and settled down there, and then the weather climate got colder again, and then they were pushed out because they couldn't do agriculture anymore. The Babylonians, Mesopotamians, Mohenjo-daro, Harappa, Incas, Mayas, many civilizations have come and gone, and our best guesses are that they always suffered from climate impacts, and it was not necessarily caused by us because we were still relatively small in number, but even though we were already beginning to change the carbon dioxide with agriculture and deforestation and so on. But the main message, kids, even half a degree change along this path here since 10,000 years ago has caused serious issues for civilizations at the time. So now we have to decide, do we have so much technology that we are just immune and invincible like Superman, that nothing will happen to us even if we keep changing climate? Well, that's what you have to decide in terms of risk. Are you sure that this technology will save you no matter what you do to the planet? Just look at the extreme events every year. What does it mean when rain falls like cats and dogs and starts flooding everywhere, and houses start getting washed away, and rivers grow large and occupy cities, and people get displaced like they did in Brazil just a few months ago, and cyclones come and bring lots of water, and heavy winter storms that put up many feet of snow, and heat waves that will kill people and crops and so on and so forth. All these changes, will we be just immune and not worry about these changes? That's the risk we are facing. So when you say, is climate change real or not, you have to also see what the risks are and then decide, should you wait till the risks become very real, or should you start planning? Mom says don't eat candies, sugar is not good for you. Do you want to keep eating till something bad happens, or do you want to say, okay mommy, I see you are already learned about how bad sugar is, so I believe you and I don't want to spoil my health, so I will start cutting out candies and enjoy it just a little bit, right? So it's about how to respond to risks before they become unmanageable. Okay, so we'll come back and continue a little bit more on how we can say again that the fossil fuels we are burning are producing CO2, and that CO2 is identifiable as coming from burning fossil fuels. So we mentioned this a little bit. I'm going to add a little bit more data on the carbon isotope. we used to do that. If you don't know what isotopes are and you haven't done chemistry or too young, as I said, you can skip the next podcast or listen and just try to understand as much as you can. And then when you get older and get to chemistry and teacher starts mentioning isotopes, you can jump up and say, I already heard about these isotopes. Thank you, teacher, to help me learn more. Okay, so see you in the next podcast with carbon isotopes.